Hey guys, welcome back. I hope you guys are doing great. Today we're going to be looking at a problem-solving question that's probably going to look very similar to what you're going to be asked on one of your tests. So we're being asked here to arrange the ribbon lengths in descending order. Now that word descending, the very first thing that we need to do, we got to write down what this word descending means. Descending is talking about listing our numbers from least, or the smallest amount, the smallest one, least to greatest. And I want us to understand that whenever we are comparing and ordering rational numbers, the strategy that has worked best for my students is to change all of these rational numbers into a form where they look like money. So we're just going to put that right here. We're going to change all rational numbers to money. And sometimes you might have an extra digit. Like let's say there was a 5 right here. And we want to change all of these numbers here in order for them to look like money. So all that we would have to do, we just have to get rid of that 5. So we're just going to just shade it in, get rid of it. So now we have 75 cents here at the top. Here we have 37 cents. But the only problem is that we have two fractions. We have 7/12 and we have 5/6. So we're going to have to do with these two fractions, we're going to have to change them into decimals. Okay, so I'm just going to put a paper over here so we could convert our fractions to decimals. And starting with 7/12, we're going to change 7/12 into a decimal. We have to remember that 7 goes in the box, 12 goes outside, the top number goes in the box, or the cowboy goes in the house, or the top dog goes in the house. And put the 7 inside of the house and the 12 outside. And all I need to do is divide. So, and it's very important, okay? The top number always goes in the box. The cowboy always goes in the house. I can't put the 12 inside. If not, I'm going to get a different answer. So how many groups of 12 can I subtract from 7? I can't subtract any, right? So I'm going to put a 0 here. 12 times 0, that's 0. I'm going to subtract 0. 7 minus 0, that's 7. Now, how many groups of 12 can I subtract from 7? Now that I can't subtract any, this is important. You don't want to add a decimal and zeros right away. You only want to do it when you can no longer subtract any groups of 12. I'm going to put a decimal here, and I'm going to add 2 zeros. So I'm bringing one of the zeros down. How many groups of 12 can I subtract from 70? Well, 12 times 5, that's 60. And so I'm going to subtract 60 here. 70 minus 60, that is equal to 10. And I'm going to bring down another 0. How many groups of 12 now go into 100? Well, we know that 12 times 9, that is equivalent. Let's see, 12 times 8, 12 times 8, I'm sorry. 12 times 8, that is equivalent to 96. So 12 times 8 is 96. I'm going to subtract 96, and I'm going to have a remainder, 100 minus 96. If I could borrow, I know the answer here is 4, but I'll just borrow for you guys. We could change this to 9, and then 10. 10 minus 6, that's 4. And we could continue going, but I like to stop here in the second digit so that our answer could be in the form of money, because it's very easy for us to compare numbers when they're in the form of money. So we know that 7/12 is equivalent to 58 cents. So let's just write that over here. 7/12, that's equivalent to 58 cents. Now we also have 5/6, so we got to change 5/6 into a decimal. So here on the other side, let's change 5/6 to a decimal. And again, which number goes in the box, 5 or 6? Got to remember, top number goes in the box, or the top dog goes in the house, or the cowboy goes in the house. Got to put the 5 inside, okay? Top number always inside. How many groups of 6 can I subtract from 5? Can't subtract any, right? So 6 times 0, that's 0. 5 minus 0 is 5. Now, how many groups of 6 can I subtract from 5? I can't subtract any, right? So now I'm going to add a decimal, the decimal here. I'm going to add 2 zeros, and I'm going to start bringing the zeros down. How many groups of 6 can I subtract from 50? Well, we know that 8 times 6, that is 48. And notice how I'm putting the 8 right above the 0 that I brought down. That's a good way of keeping all of our numbers aligned. 8 times 6 is 48. 50 minus 48. If I were to borrow, 10 minus 8, that's 2. 4 minus 4, that's 0. I'm going to bring down the next 0. Since I brought it down from the hundreds place, I got to put my answer right above it. How many groups of 6 can I subtract from 20? You know that 6 times 3, that is 18. You guys got it? 20 minus 18, we have a remainder of 2. And we could continue going, but I like to stop in the second digit to the right of the decimal or in the hundreds place because I want our decimals to look like money, and I want us to think of money when we compare them. So we could kind of see 5 6 as 83 cents, and we could see 7 12s as 58 cents. So let me go ahead and put these two numbers over here, or the one number that we're missing. So we know that 5 6, that is equivalent to 83 cents. Now we were to compare all of our numbers now. We've got 75 cents, 58 cents, 37 cents, and 83 cents. And if we have to put them in order from least to greatest, well, which is the smallest amount? Again, 75 cents, 58 cents, 37 cents, or 83 cents. Well, 37 cents is the smallest amount. You guys agree? So I'm just going to put here 0.37. And we got to remember that when we're listing them, we're going to list all of our numbers in the original form, not in their decimal form. Well, this one was in decimal form, so we can leave that one like that. Then what would the next number be? After 37 cents, it would be 58 cents, but I'm not going to list 58 cents. I'm going to list 7 12s because that was my original number. So I'm going to put 7 12s here. I'm going to cross this one out. And after 58 cents, what would be next? 75 cents. That was in decimal form. And then our last number, our greatest number, is 83 cents, which is 5 6. So I'm going to list again the fraction. I'm not going to list the decimal. So this is probably the best strategy that I have come up with and that my students really like. We want to change all of our rational numbers into decimals, and we want those decimals to only go to the hundreds place so that they can look like money. Because once we change them all of our numbers to decimals, it's very easy to compare them. Decimals that look like money, I'm sorry. So again, 75 cents, 58 cents, 37 cents, and 83 cents is very easy for us to be able to compare them and put them in order from the smallest to the greatest. So I hope this video helped. Thank you very much. We'll see you guys next time.